question 3b, I and ii. Now this is a Newton's approximation question. So it asks us, so in considering the function 3 ln x minus x, show that y equals 3 ln x and y equals x intersect at a point P such that P's x-coordinate lies between 1.5 and 2. So when we think about finding points of intersection, I think we should normally equate these two graphs. So we'll consider the y values, so we let the y values equal each other, as that's where the point would meet, and thus we get 3 ln x minus x equals 0. And that is our fx. So all we need to consider really is where f of x equals 0. But as this is a tricky problem to solve with our mathematical knowledge, we have to approximate. So to find a point where x equals 0, we normally test whether the function lies above and below the x-axis. As you could consider a graph here, this point is positive in its y value, but this point is negative. So between them, there must be a point of intersection. So we'll do the exact same with our f of x. So as we know, we want to show that the point P has its x value between 1.5 and 2. So we'll consider f of 1.5. So that would mean 3 ln 1.5 minus 1.5, which approximates to minus 0.2836. And now also we'll consider f of 2, which is 3 ln 2 minus 2, which also approximates to 0.07944. Now if you realize, this one is negative and this one is positive. So in doing that, we realize that in this situation that I showed here, this is the exact same case. So that must mean that a root lies between 1.5 and 2, such that f of x equals 0. So in saying that, we say that since the product of f of 2 and f of 1.5 is less than 0, and that f of x is continuous for this interval, we must know that the x-coordinate of P must lie between 1.5 and 2. Hence, part I is solved. Now, moving on to part 2, we're asked to approximate this coordinate of P to a higher degree by using Newton's approximation. So, as you all know, Newton's approximation states that the intercept can be found via this method. So it's asked us to start with the approximation of xp equals 1.5. So in doing that, we know that our x of 0 is 1.5. So we now know that the second approximation, so we'll call it 2, is given by, we'll substitute, so 1.5 minus f of 1.5 over the derivative of f 1.5. But we don't know what our derivative is yet, so as you know, we know how to differentiate our log functions and our x's. So we know that the derivative here is 3 over x minus 1. So now we know if we substitute 1.5 in here, we'll get 3 over 1.5 minus 1, which is 1. So now we just substitute. So we already knew what f of 1.5 was from our previous part. So now we know that x over 2 has to approximate to 1.5 minus, so our 1.5 was negative 0.2836. And since we just learnt from here that f dash x equals of 1.5 is 1, we do that. And with our calculators, we will learn that this reduces down to 1.736, and that goes on for a while. and now to 2 decimal places, so we round up. So now we know that our second approximation is approximately 1.78, and that's the problem.